Hi, Math 95. So now that we've gone over some of the other examples on the notes that we didn't do in class, I wanted to also move on here to the synthetic division notes. If you were in class or if you looked at the notes, you see that there was the set of notes for synthetic division where we started out by doing the same question using long division and synthetic division. Synthetic division is a little bit of a shortcut. Um, so we can see that our quotient and our remainder are the same for both of these. So when we're doing synthetic division, we start out by putting just the coefficients from our dividend here, and we put our C from our divisor right here. C meaning we can only use synthetic division if our divisor is in the form x minus C. So if I think about x minus 2 and kind of match it up with x minus C, we can see that C is 2 in this case. So I start out by bringing down my leading coefficient, just bring it straight down to the bottom here. And then the two words that I want to remember when I'm doing synthetic division are to multiply and add. So I multiply 2 times 1 and I get 2 comes here. 2 plus 2 is 4. 2 times 4 is 8. Negative 7 plus 8 is 1. 2 times 1 is 2. 5 plus 2 is 7. This last number in this last row is my remainder, and my quotient is the next, all of the next numbers. Going from right to left, it goes from constant x squared. If it kept going, it'd be x third, x to the fourth, etc. Okay, so we get the same answer. And we talked about in class how you can kind of see these same numbers. Here's a 4, here's a 4 over here, right? It's 2 minus negative 2. Because this is minus here, we have just the positive here. That's why the difference between adding in one and subtracting in the other. But we can see the same numbers, right? Here's 8 minus negative 8. Negative 7 minus negative 8. There's my 1 that comes from that. And then 5 minus negative 2 is like 5 plus 2. There's where my remainder comes in. So let's take a look. We had some examples that we did with synthetic division. And then we can look at some extra practice problems. Now I have 4 problems here. The first one and the 2 on the following page all can be done with either method. This one right here must be done with long division because there's a 3x there, not just an x in the divisor. So I'm going to show you how to do these both ways. So let's go ahead here and set this up as a long division problem. Now when we look at the dividend, we have to make sure we're not missing any terms. Well, I have x to the 5th, x to the 4th, 3x to the 3rd, minus 3x squared, plus x minus 8. So I'm not missing any terms if I go from highest to lowest with the exponents. So I have x to the 5th minus x to the 4th plus 3x to the 3rd minus 3x squared plus x minus 8. And my divisor goes out here. And remember when I'm doing long division, I really just want to pay attention at first to the leading term for each polynomial. So my x and my x to the 5th. And I think about x times what would give me x to the 5th, or I can think x to the 5th divided by x gives me what? It's going to be x to the 4th. So x to the 4th times x is x to the 5th. X to the 4th times negative 1 is negative x to the 4th. Okay, now I have x to the 5th minus x to the 5th. That cancels out. Now this is a little bit unusual because I now have negative 1 plus 1 that also cancels out. So I end up with 0 x to the 4th, and then I'm going to bring the rest of this polynomial down. Okay, so now again I'm looking at leading terms. So x times what is going to give me x to the 4th? Well, 0x to the 4th, sorry. Well, it can really just be 0, right? But let's sort of follow this pattern and have 0x to the 3rd. So I multiply those, I get 0x to the 4th, just 0. 0x to the 3rd times negative 1 is still just 0. We can put x to the 3rd there to kind of keep that going. So this cancels out. 3 plus 0 is going to be 3x to the third, bring everything else down. So again, I'm looking at leading terms here. X goes into 3x squared. That's going to be 3x, sorry, into 3x cubed. That's going to be 3x squared number of times. And then if I take 3x squared times x gives me 3x cubed. 3x squared times -1 is -3x squared. I'm running out of room here, but we'll kind of go over here. So this cancels out. Again, we have this sort of unusual situation where these cancel out also. Let's just bring this down. This is going to be plus 0x, right? X times x gives me the x squared, but 0 times 1 is going to be 0. I multiply these and I get 0 for both of these. So this cancels out. 1x minus 0x's is 1x. And then if I look and I say, okay, how many times does x times what gives me x? Well, that's going to be plus 1. So I multiply both of these. I get 1x minus 1, subtract. -8 plus 1 is -7. Let's look at it in synthetic division now. Okay, so we write the symbol sort of backwards. If I have x minus 1 as my divisor, I want to match that up with x minus c. My c is going to be 1. That goes right over here. I put the coefficients here. So x to the 5th has a coefficient of 1. X to the 4th has a negative x to the 4th has a coefficient of -1. And then we have 3, -3, 1, -8. So I bring the first one down, and then my two words are multiply and add. So multiply, add, multiply, add. You have to really think carefully because when you add 0, you get the same thing. When you multiply 0, you get 0, right? So you're going to have to think about which one you're doing in each case. 1 times 3 is 3. -3 plus 3 is 0. Now when I multiply, I get 0. I add, I multiply, I add. All right, so my remainder is this last number right here. These are my quotient. And remember, from right to left, my exponents go up. So my constant, which really has an exponent of 0, x to the first, x to the second, x to the third, x to the fourth. So when we have our quotient and has zeros in it, we don't really have to write them in our answer. So we could write our quotient as x to the fourth plus 3x squared plus 1 with a remainder of -7. Or if we wanted to put the zeros in, it would look more like this one with this remainder of 7, right? And of -7, sorry, and that would be okay also. But we generally don't feel the need to include those that have a 0 in front of them. All right, let's go on to the next one. Now this next one we said cannot be done with synthetic division because this is not just x plus or minus a number. So we're going to have to do long division here. If I look, I have x to the third, x to the second, x to the first, and a constant number at the end. So I do not need to include any more terms with a 0 in there. So I'm just going to write out my dividend. Okay, so I look at the leading terms, and 3x times what gives me 3x cubed? Well, the 3 just gets multiplied by 1, but x gets multiplied by x squared. So 3x cubed plus x squared. Where did I get this? Well, I took this x squared and I multiplied it by 3x, and then I multiplied it by 1. We're going to put those in parentheses and subtract. So 3 minus 3 is 0. That goes away. -5x squared minus 1x squared is -6x squared. I bring down the rest. Okay, now I'm looking at leading terms again. 3x times what gives me negative 6x squared? Well, 3 has to be multiplied by negative 2 to make it negative 6, and x has to be multiplied by another x to make it x squared. So now I multiply these. Negative 2x times 3x is negative 6x squared. Those first two should always match, okay? Negative 2x times 1 is minus 2x. And I'm going to subtract these. Negative 6 plus 6 cancels. 10 minus negative 2 is like 10 plus 2, which is 12. And I bring down the rest. And again, I'm just looking at the leading terms. So 3x times what equals 4x? Sorry, equals 12x. Well, 3 times 4, positive 4, is going to be 12. And x doesn't need to multiply by anything else because I just need an x there. So 4 times 3x is 12x. 4 times 1 is 4. I subtract. 12 minus 12 cancels out. Negative 3 minus 4 is negative 7. So my quotient here is x squared minus 2x plus 4. My remainder is negative 7. And again, to check your answers, don't forget that to check your answers, you can multiply, right? So I could multiply, I'm not going to do the whole check, but let me set it up for you. I would multiply my quotient times my divisor. Now in this case, I also have to add in or subtract, because it's a negative, my remainder. So I'd multiply these together, just like we did in the multiplication part of this chapter. And then I would add 7 at the end, and that would give me what I have here. I would add negative 7, sorry. Okay, so let's move on. The next two we can do either way. We can do by long division or synthetic. I'm going to do them both ways. Again, it'll be a little quicker than last time, than example 3, because these are much smaller polynomials. So here I have x squared, x, and a number. I do not need to add anything to that. X squared plus 3x plus 5, and x plus 1 is my divisor. So again, I look at my leading terms. X times x gives me x squared, or x squared divided by x is an x. X times x is x squared. X times positive 1 is 1x. I put it in parentheses and subtract. X squared minus x squared cancels out. 3 minus 1 is 2x, and I bring down the rest of my dividend. I again look at leading terms, thinking about how do I get this to this? This times what gives me this term? Well, there's a 1 here, right? So 1 times positive 2 will give me the 2, and I already have the x, so x times 2 will give me 2x. So now let's take this and multiply. So 2 times x is 2x. 2 times 1 is 2. 5 minus 2 is 3. So my quotient is going to be x plus 2, and my remainder is 3. How do I know that that 3 is a remainder and I don't keep going? Well, x times, it can't multiply by something to just be 3 and get rid of that x, right? Not something, unless it had a negative exponent, which we don't want there. All right, so let's do it with synthetic division now also. 1, 3, and 5 are my coefficients from that dividend. So let's think about this. I want to have x minus c. Well, I have x plus 1, which won't really line up, right? Well, let's think of it as x minus negative 1. X minus negative 1 is the same as x plus 1, but now I have x minus something. So my c is negative 1, so negative 1 goes over here. Okay, so I bring down this leading coefficient. Negative 1 times 1 is negative 1. 3 minus 1 is going to be 2. Then I multiply, and then I add. So again, now, this is my remainder. These are my quotient, okay? This is a plain old number. This is x to the first power. So my quotient is x plus 2. My remainder is 3, just like I got the other way, obviously. Okay, I'm going to keep scrolling. Obviously, you can pause the video if you need more time to look at something. All right, so last one. Again, we're going to do it both ways. If I look at this, I have x to the third minus 2x squared minus 4. I do not have an x value there, a term with just x to the first power. So that's what I need to add in here. What I'm going to do is I'm going to rewrite this. I'm going to think of this as x cubed minus 2x squared plus 0x minus 4. And that's what I'm going to write in here when I write in my dividend. Okay, so I'm going to give you just a second while you're watching this. Obviously, you can just pause it also if you need more time. But I want you to just think about what value or what term is going to go right here. X times what would give us x cubed? If you get that, then go ahead and multiply by both of these. Okay, so hopefully you decided that x times x squared is going to give us x to the third. And then I can go ahead and multiply. X squared times x gives us x to the third. And then x squared times negative 3 is minus 3x squared. And this cancels out. And negative 2 minus negative 3 is like negative 2 plus 3, which is going to be 1. So I just have x squared. And then I'm going to bring everything else down. And I'm again going to look at leading terms. So x times what gives me a positive x squared? Well, that's going to be plus x, right? X times x is x squared. X times negative 3 is negative 3x. Remember, this is why we need to fill in that 0 if we're missing a term, okay? If I didn't have this 0 here, I'd have x squared minus 4, and 4 and negative 3x don't line up, and it would kind of mess up what I have to do for the rest of this problem. So these cancel out. 0 minus negative 3 is like 0 plus 3. So 3x, and then I bring the rest down. I look at leading terms. X times what needs to be there to give me positive 3x? Well, it's 3. X times 3 is 3x. Negative 3 times 3 is negative 9. I subtract. Negative 4 plus 9 is 5. So my quotient is x squared plus x plus 3. My remainder is 5. Okay, let's do synthetic division. So we draw our little box the opposite way. Here I have x minus 3. So if I think about x minus c, c is going to be positive 3. And I put the coefficients in again, leaving that 0 there as a placeholder. All right, so I bring this one down. 3 times 1 is 3. Negative 2 plus 3 is 1. Remember, we multiply and we add. We multiply and we add. Here's my quotient. Here's my remainder. Constant x squared. So my quotient is going to be x squared plus x plus 3. My remainder is going to be 5. Now, anytime we have a coefficient of 1, you can write it in, you just don't have to. So my quotient could also be 1x squared plus 1x plus 3, right? That's perfectly fine also. Again, remember to, if you want to check it, you take your quotient times your divisor, and then if you have a remainder, you have to add that in or subtract it if it's negative at the end, and you'll end up with what you started with. Alrighty, so hopefully that helps with the synthetic division. I know it's a little different, a little new, but hopefully you can kind of see how that works now as well. Thanks, guys.